Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So in this video, we continue our discussion about equation of the plane. So now we discuss about the question and examples regarding equation of the plane. So we start with the example 11. So I write down the situation above here. Given a point and vector normal to the plane. Right, so find the vector equation and Cartesian equation of the plane that passes through a point and it is perpendicular to the vector 3i plus j minus k. Okay, so this is what we call a point here and perpendicular vector, so this is normal to the plane. So as you can identify here, so the position vector 2, -1 and 3, and then the normal 3, -1 and -1. So since it is very direct, so we just straight away substitute into the formula r dot n equals to a dot n. So substitute n with 3i plus j minus k. So on left hand side we put ijk, okay? Because usually the answer for vector equation we have ijk. In other hand, on the right hand side, since we do the dot product, so we just use the H bracket here, and then we solve the dot product on the right hand side. So it will be 6 minus 1 minus 3 from the dot product, and the answer, so r dot n equals to a dot n, which is 2. Okay, right, so this is a vector equation. Next, the question asks to also find the Cartesian equation. So we will substitute r here with si plus yj plus zk, okay, to find the Cartesian equation. So we substitute here. So when we use the h bracket here, and also we also replace the h bracket because we want to do the dot product. So no more ijk, okay, we just focus on the dot product. So straight away 3x plus y minus z, okay, on the left hand side after we put together s, y, z here, equals to 2, right? Very simple. Okay, for the example 11. Right, next example 12. A plane contains point A, B, and C. So from here we know that the situation in this case is given 3 points. Right, so the question is find its Cartesian equation of the plane. So as you can see from the diagram here, from these 3 points we will form a 2 vectors. That is vector AB and vector AC. And then later, to find the normal to the plane, we will cross product vector AB with vector AC. So first find out vector AB. So we will get 0, -3, and 1. And then vector AC will be 1, -4, and 2. So from here we can find out the normal to the plane. So that is vector AB cross product with vector AC. So from vector AB 0, -3, and 1, and then from vector AC 1, -4, and 2. So remember how to perform the cross product. So I won't show the details here. So we just straight away give the answer here. That is the normal to the plane would be -2, 1, and 3. Right. So after we obtain n, then we can proceed to find the equation of the plane. So remember the formula r dot n equals to a dot n. So here is our n, and then as you not show here, so since we have 3 points here, then we put a at the front here, so we choose point A here as our A. So 1, 3, and 1, okay, when we change into position vector, so we will dot product with the n. So the dot product would be -2 plus 3 and plus 3, okay, after we expand. And then on the left hand side here, we replace r with x, y, z, okay, and then later we will put x, y, z up after the coefficient. So it will be -2x plus y plus 3z, okay, so here will be equals to 4. Okay, so that's for example 12. Right, next for example 13. So find the equation of the plane pi1 which contains a point 1, 2, 3. So here it given a point and is parallel to the plane pi2 with the equation r dot n equals to 5. So this say the equation parallel to another plane. So when we sketch the diagram here, so the red one is our plane and then parallel with another plane pi2. So from pi2 we got the normal n2. So this n2 actually we can equate with n1, right? So from the point given we can write down our position vector, and then as I said, n1 we can equate with n2, so we can straight away find out our n. Right, so since we already determined our a and n, then we can substitute into the equation. So the vector equation r dot n equals to a dot n. So remember, we substitute n left hand side with ijk, and then right hand side without ijk in the h bracket, because we want to do the dot product on the right hand side. So we solve on the right hand side. So 2 minus 2 zeros, we can cancel out. So we got only positive 3 right on the right hand side. So I write down again on the left hand side because this is our final answer. That is the vector equation of the plane. Okay, because the question asks about vector equation. Okay, so that's for example 13. Then we move to the example 14. So in example 14, the plane pi contains point A, that is 1, 2, 3, and B, negative 1, 2, and 5. So our situation here given 2 points. And is perpendicular to the plane. So another situation, perpendicular to another plane. So the question, find the Cartesian equation of the plane pi. So already sketch the diagram here. So this is our plane, the yellow one. So the perpendicular one here is another plane. So from the another plane here, so we will get n2 from another plane. And then from point A, from the 2 points here, point A and point B, we can connect and find out vector AB. So as you can see here, we find out vector AB. So OB minus OA, so we got negative 2, 0, and 2. Okay, so this is vector OB. And then from the another plane, we got N2, that is 3, negative 1, and 1. And then next, to find our normal to the plane, so we have to do the cross product, okay? Because if we do the cross product, we will get our n. So our n, we have to do the cross product with vector AB and n2. So this is our AB earlier, we already calculate, and then this is n2 from another plane. So you perform the cross product here, and then I just give the answer here, that is 2a and 2. Okay, after we find out our n, then we can find out our equation of the plane. So we have 2 points. Remember, we have point A and point B. So here we choose point A. Okay, usually we choose the first point, that is point A. So point A, we dot product with the n here, and then left hand side here r dot n. So remember, as I said in the previous example, on the left hand side we stick with the ijk. So on the left hand side without ijk, but we have a h bracket here. Okay, so we expand on the left hand side and on the right hand side. So we got 24. And then on the other hand, since the question asks about the Cartesian equation, so later on we also need to replace here with the h bracket, because we want to dot product with the r, because r we already replaced with x, y, z. So when we do product, so we just put x, y, z after the coefficients, so will be 2x plus 8y plus 2z equals to, here right hand side will be 24. Right, as you can see in our answer here, in certain question they divide by 2, but we just can leave the answer just like this, no need to divide by 2 unless the question asks you to simplify. Okay, so no need to simplify unless the question stated, so just give your answer just like this. Okay, next in the example 15, find a vector equation of the plane that contains a point. So given a point and is perpendicular to the line with the equation R. So perpendicular to a line. So that's our situation in this example. So let's see how we solve this question. So from the line, here we got V, right? From the line, okay, vector parallel to the line. So we got V here. And then let's see. So this is our plane. And this is our line, okay? The line will perpendicular to the plane. So as you can see here, since the line is perpendicular to the plane, the V from the line here is actually would be our N. Okay, so the blue here is the V and the red one here is our N. So since on the same line parallel, so we can use the V as our N. So N here is 3, -1, -1. So since we already determined there is N also a V and a point already given, then we can proceed to find the equation of the plane. So substitute N here, and then A dot N, we find out the dot product on the right hand side. So it would be 1, and then left hand side, just repeat the answer because the first line here, because the question asks about the vector equation. So no need to expand with x, y, z, okay? Right, so next in example 16, determine the Cartesian equation of the plane that passes through 4, 0, and -2. So given a point, okay, given a point passes through that is on the line or on the plane and perpendicular to the planes, the first plane and the second plane here. So means that our plane is perpendicular to another two planes. So as you can see from the diagram here, our plane is the green one at the bottom, at the base here, and on the left we have a plane pi 1, and at the back we have plane pi 2. So from plane pi 1 we have N1, and from plane pi 2 we have N2. So as you can see here also, in order to determine our normal to our plane, that is N, we have to do the cross product between N1 and N2. So N1 and N2, when we cross product, we will get our N. So first our first step is to determine N1 and N2 from the another two planes. So from the first plane here, our N1. So we just look at the coefficient on the left hand side here. So 1, -1, and 1. So that will be our N1. And then from the N2 here also, we know is positive 5 is a constant, that is A dot N. So don't bother about this. So just focus on the coefficient of S, Y, Z here, because the coefficient here represent the N. So here 2, 1, and -4. So that will be our N2. Okay. So after we figure out N1 and N2, then we can do the cross product between N1 and N2 to find out our N. So after we do the cross product, so the answer will be 3, 6, and 3. Right, so after we determine our n and a was already given, then we can straight away find our equation of the plane. So the equation of the plane, r dot n equals to a dot n as usual. So n here on the left hand side also as usual, we put ijk on the right hand side already in h bracket. We of course we want to do the dot product. But the question asks about the Cartesian, right? So later on the left hand side also we need to change into the h bracket here, 3, 6 and 3, and then out also we replace with xyz. Okay, so on the right hand side we already simplify, do the process of the dot product. So the result from the dot product would be 6 on the right hand side, and then on the left hand side we already do the dot product, so will be coefficient, okay, and the xyz, so 3x 6y and 3z equals to 6. So that will be our answer for example 16. Right, next for the example 17, a plane contains a point 101, so given a point, and a line L, so a line also on the plane. So this is the equation of the line. Remember what kind of equation this? Yeah, this is a parametric equation. So find the equation. So as you can see here, this is our plane. This is a point on the plane, and this is the line. So the line also contains point B. Where we get the point B here? So actually point B here, we can find out from the constant here. So 1, 3 and 2. So this will be our constant that is also represent the point B. Okay, 1, 3, 2. So as you can see here, how we get 1, 3 and 2. And then after we obtain point B, and also we already know point A from the already on the plane, then we can find out vector AB. Okay, find out vector AB. And then from the line also we already know the V, right? Okay, so when we do cross product between vector AB and also the V from the line, then we can get our N. So this is what we do. So the first step, this point A already on the plane. So point B is also on the plane because it is from the line, as I said earlier. So from these two, we will do the we will find out the vector AB. So the vector AB would be 0, 3 and 1. Okay, and then from the line also, as I said earlier, we can find out V, right? Vector parallel to the line, that is 1, negative 1 and 1. And then later on we know that we have to do cross product to get N, right? That is the cross product between AB and also V. So let's move to the next slide. So this will be our cross product between vector AB and also vector V from the line. So this is cross product, and then solve it, then we get 4, 1 and negative 3. Okay, so after we find out the N, then we can find out our equation of the plane. So remember r dot n equals to a dot n, so replace our N here in ijk, and then right hand side already in h bracket. So as usual, we will solve the dot product on the right hand side here. So we got 4 plus 0 minus 3, and then we got 1. So since the question asks about vector equation, so no need to expand R. So we just copy it on the last line. Okay, that will be our final answer. That is the vector equation of the plane. Okay, so that will be our last example in this video. So before we end of our video, let's take a look about the few points. So remember, before dealing with the equation before dealing with the equation of the plane, so make sure you already understand the concept of the scalar product. Okay, as we can see in the solution, right? It's very we widely use the scalar product and also the vector product. Okay, so make sure you already understand how to use scalar and vector product. Okay, next, in all situations, you are required to understand first how to determine the normal vector to the plane and also the position vector A. And then remember, I already discussed this one in the previous video. So make sure you read the diagram at the end of the previous video. That is the video regarding 5.1D concept of the plane equation. In order to have a better understanding about how to determine normal n and also position vector A in the different situation. If I'm not mistaken, we have a 7 situation, okay, in that diagram. So make sure you read all the 7 situation, different situation of the plane in order to understand how to find out n and A in each cases. But if you cannot memorize all the various situation, so maybe a sketch will also will be a great help. Okay, but I think from my personal experience, if you in certain cases, if you want to sketch, you also need to know a bit about the various situation. Okay, how is it is parallel to the plane, how it looks like, parallel perpendicular with two plane, how it looks like. If you cannot get a basic idea about that, you also cannot sketch properly. Okay, so these two are actually very important. Okay, in order to make sure you understand how to find out the equation of the plane. Okay, so that's all about the equation of the plane. So stay tuned for the next video. We will discuss about angle between two planes in the next video. So remember, this subtopic regarding especially about equation of the plane is not easy, actually is a quite difficult. So make sure you fully understand about each example that we already discussed, and make sure you answer all the tutorial question in order to make sure you fully understand about the various situation of the equation of the plane. Okay, so thank you very much. Until then, bye bye.